can come in many different shapes and sizes, and each design produces different amounts of electricity. To get the ultimate windmill, you should first test a variety of designs, ranging from a rectangle, a triangle, and a trapezoid. The difference in shape changes many factors, like the total area of the blades, the weight of the blades, and how aerodynamic they are. On a large scale, these differences in design can make or break the ability to power entire countries with clean energy.
Before beginning your experiment, you must design each blade, first starting with the rectangular blade, which consists of 3 30 by 6 centimeter pieces of cardboard. A tip from experience to making your shapes is to ensure the corrugated part is on the bottom of the blades as opposed to the sides, as it will give the blade more vertical support.
Next, you need to make your triangles. To make the triangles, we use a 6 centimeter base and a 30 centimeter height. However, at the top, you must find the exact center of 6 centimeters and cut from the edges of the base to the middle point. Cutting slanted sized triangles is hard, so from experience, we recommend to use box cutters as opposed to things like saws or scissors.
Finally, you make the trapezoid by cutting half of the square on one side and using the triangle method for the second half, and cutting from the top central point. By now, I'm sure you've noticed the designs of our blade. While making them, you should use a variety of your team members' favorite colors and draw your favorite patterns.
Before testing, you must attach each of the sticks into the centers of your blades for added stability. This was done by puncturing the blade with a pointed stick or pencil, inserting glue, and then inserting the real stick. It's important to be extremely careful when doing this, as pushing towards yourself can cause large tears in the cardboard.
Now it's time to put your blades to the test. Attach them to the hub at 120 degrees of a difference. We recommend a slight tilt across them. We personally only did less than 20 degrees. Each be careful with some issues with the hub stability that can be fixed by attaching a screw for support. It's time to receive our data. We were mainly looking for which turbine could produce the most amount of energy. Our hypothesis was that if the shape was a trapezoid, then it could produce the most energy. However, our answer ended up being the rectangular blade.
The rectangular blade produced a total of about 0.92 joules of energy, as opposed to the 0.13 joules for the trapezoid and the 0.28 joules for the triangle, which are very small in comparison. It also had an average potential of 0.96 volts, compared to the triangle's small 0.57 and the trapezoid's 0.36. This means that overall the rectangle was what we were looking for, and what might help you make the best turbine. If it was more energy efficient, and on a real large-scale wind farm, this design could be the best of 3 to power country.
The rectangular version was also superior in the sense that it produced not only more current, 32.16 milliamps compared to 17.98 milliamps for the triangle and 12.01 milliamps for the trapezoid model. The rectangular version is also superior in power with 31.19 milliwatts versus 9.87 milliwatts for the triangle and 4.45 milliwatts for the trapezoid model. Overall, it's clear that the rectangular design outclassed the rest of the shapes in every department.
If you're looking to create the most efficient wind turbine design with recycled material from your home, evidence suggests that going for a rectangular model can outperform triangle and trapezoid models by a landslide. We hope this tutorial not only taught you how to make the best wind turbine model, but that you also learned something along the way.